minute passed.
Okay.
The stage is yours. Please go on.
Yes, and hello everyone, and thanks everyone for coming in and to welcome our webinar about cost-saving strategies in data management and infrastructure security. And I will start with my part. It's about securing your infrastructure at no cost. It's actually a byte. So, and hello again. My name is Boris, and today I will tell you how I secured the infrastructure as code pipelines using only 3 tools at one of our projects, and how you can do the same to improve the security and save the budget at the same time. Okay, so let's go. And first of all, let me introduce myself. As I already said, my name is Boris, and I'm information security engineer and enthusiast, currently located in Prague, Czech Republic. This is me in the photo, acting cool. I am AWS security certified. Also, I like to play guitar and Pokemon Unite. I like to solve chess puzzles. And my playlist is at top of Spotify if you are searching for coding. So what an achievement, right? Okay, that's all about me. Now let's get back to our topic and try to understand why we need to secure our pipeline. Why not to deploy infrastructure as is? And the answer is simple. It's cheaper. It's cheaper to fix vulnerabilities earlier than to fix them when it's already a production. This cybersecurity practice is called shift left, which means that we should try to shift our security tools and detection mechanisms to the beginning, to the start of the development lifecycle, to detect vulnerabilities and misconfigurations as early as possible. And thanks to infrastructure as code, now we can apply this idea to our infrastructure and not only applications. Imagine the simple example. We have an unencrypted AWS RDS instance, and the auditor comes and says, hey, your database is unencrypted at rest, and you have to fix that. And it's actually not so easy when the database is already in production. To minimize the downtime, you will have to create new encrypted database instance and use database migration service to copy all the data. This is a huge effort, and all that wouldn't happen if we detect that database is unencrypted even before it's been deployed. So to understand what we can do, firstly, we have to understand what we have. During the project, we had several development teams that were writing code using AWS CDK. It is an open source development framework to define cloud infrastructure in code using high-level object-oriented abstraction and provision it through AWS CloudFormation. So basically, you can write your infrastructure using TypeScript or Python or Go, for example, and convert this code into CloudFormation templates for further development, for further deployments. And we also were using GitLab for CI/CD pipelines. Additionally, we have a limited budget, so the solution should be cost effective. And we only have one security engineer to find and implement the solution. Considering all that, I've collected the requirements. First of all, since CDK code converts to CloudFormation, the solution should support CloudFormation templates, right? Also, we don't want developers to control the scanning process, rules and exclusions. So all these things should be external to developers' pipelines. And additionally, we want some kind of centralized storage for our rules and exclusions. And what we also need is to create per resource exclusions. For example, if we want to suppress some findings for a specific bucket or a specific database or something like that. And after that, I checked the market to find out if something similar already exists. And I checked actually a lot of tools, just a lot. And I know that such tools as Sneak, for example, and Chekhov are super popular. And that's because it's a great tools actually. But Sneak costs money. And to create exclusions in Chekhov, you have to write comments like directly in the template. So if you're writing, for example, Terraform, you have to leave the comment directly in the resource, and which we cannot accept, because in that case, developers can bypass our security controls. I don't know actually how that happened, but a lot of tools use this approach. When to make some exclusion, you have to leave the comment directly in the template. So that is not what we are looking for. And fortunately, we have a winner here, and it's Regular. Here on the slide, you may find the link to the GitHub repository. And Regular is an open source tool that evaluates infrastructure as code files for security and compliance violations before deployment, and uses a library of rules written in Rego. Rego is the policy language used by Open Policy Agent, and you can integrate Regular with, I believe, any CI/CD tool such as Jenkins, Circle CI, AWS Code Pipeline, GitHub, GitLab, doesn't matter. And it also supports CloudFormation, JSON, and YAML templates, Terraform source code, Terraform JSON plans, and even Kubernetes YAML manifest, actually. Unfortunately, I found out that the default Regular rule pack is a bit small, and I instantly noticed that, hey, we can detect that issue, we can detect this issue, but the major benefit of Regular can fix that. And it is its extendability. Since it uses Rego, we can write our own rules and create actually any security gateways we need. Right. Now let's jump into the scanning process and look at how it all works together. So we have the application repository here, where some developers team creates infrastructure code such as lambdas, API gateways, databases, buckets, and so on. And I created a lambda here, which is triggered by pushes in the application repository. This Lambda sets the pipeline status of the commit to pending and triggers the scanner repository pipeline. After that, here in the scanner repository, all the security magic happens, and depending on the result, the status of the application repository here is updated once again to green or red. But what actually happens in the scanner repository? At this point where I said security magic. As I already mentioned, we used AWS CDK for writing infrastructure code. And the pipeline is looking for every cdk.json file to run cdk synth command and generate all the CloudFormation templates. After that, we are ready to scan, and the pipeline runs regular against all these generated templates. And when we get the result, my custom scripts create a beautiful table to make results more human readable. And another script sends result to SumoLogic, which is our log management system. And depending on the result, the application pipeline status is updated. And it also sets up a link to the scanning pipeline. So developers can go directly to the scan results just by clicking on the status. Let me show you how it looks like in the wild. And here we have a list of generated templates here, the config file applied, and secrets discovery stage, which we'll talk about a little bit later. Also, we have this beautiful human readable table where you can find the resource ID, resource path, and rules description, severity. And additionally, if developers need more details about the results, they can download the full report from this artifacts section. All right. How can we make exclusions and write rules? Firstly, let's take a look at the scanner repository structure. Here we have a pipeline file, a folder with rules, a folder with this helper scripts for table creation and log sending, and the configs folder where I store all the exclusions. As you may see, inside we have this config.rego file. The file contains exclusions for all the projects and is applied for every scan run. Additionally, I repeat the project path structure, and each application repository can have a separate exclusions file, like on the screen. Here I have the repository located in /platform/IaC security test. So I have a platform folder here in my configs, and also IaC security test.rego file. And this file contains exclusions only for this my test application. And every time the scanning process runs, it actually checks if there is a special config file, like in this case. If there is no such file, that's absolutely fine, that's okay. And only the general file will be applied, this config.rego, and scan will go normally. And this is what the config file looks like. The syntax is really easy, and in these files, we can suppress rules for some specific resources, for example, for one bucket or for one API gateway, doesn't matter. In that case, we should use the waivers construction, like here at the top of the config file. And if we want to disable the rule from running at all, we should use the rules construction, like here. And this is it. It's just so simple, and no need to document all these exclusions or write comments in the code or create a Confluence page with exclusions, because if you want to find out what exclusions some applications has, just open the config file and everything is here. And here is what the rule looks like. As you may see in the metadata here, you can define the rule ID and title and write some custom description, severity, and remediation steps. And actually, you may add anything you want. Further, we have an input type, which is CloudFormation in our case. And as I already said, it's also support Terraform and Kubernetes templates. And further, we have resource type, which is S3 bucket in our case. And we want to deny every bucket that has the access control parameter set up to public read and write. So basically, you may write the rules for any parameter you need and define what values these parameters should have. And Rego is super flexible language. It supports regular expressions, different data types, and logical operations. And if you go to the regular documentation page, you will find a comprehensive guide on how to write custom rules. In this webinar, I won't tell you on what you should write and what you should detect, because this is another topic. But anyway, let me give you some advice here. No one knows actually your applications better than you, and probably you already know the most applicable threats for your app. If you have a threat modeling process, that is great, and use this knowledge to create security gates. And also, you may follow best practices, such as, for example, AWS well-architected frameworks, and additionally use the security reports you already have. Maybe you have Security Hub enabled or AWS config enabled, and you may grab some rules ideas from there. Or, for example, if your company ordered a penetration test, and then you most likely have the pen test report, use all this knowledge to write better rules. All right, so we are done with regular. And the additional step to increase the infra as code security I've made is secret scanning. And one more step I've added to the pipeline is the credential scanning with Trufflehawk. Here again, the link to the GitHub repository. And Trufflehawk is a free Python-based tool that is designed to search source code for high entropy strings that can represent secrets, passwords, or API keys. And what is great about this tool is that you can eliminate false positives with over, I believe, 700 secret detectors that support automatic API verification. So, for example, if Trufflehawk found some API key like on the screen, we have IP API service, and it found API key. So Trufflehawk can actually make a request to this IP API service and check if this key is still valid. So we'll get minimum amount of false positives. All right, we came to an end actually, and what are results? What do we have now? And as a result, I've built a separate security pipeline with a centralized configuration and huge actually rule sets, and used only free tools for that. Of course, the solution itself is not completely free because we have to pay salaries to our engineers, and we have to invest some time in writing and managing rules. And that is the cost of being self-efficient. I believe that in the long-term perspective, with the sufficient maturity level of security engineers and proper time and resource management, this kind of solution could be still very, very effective. This is it. Thanks everyone for your attention. And if you have any questions, please leave them in the chat or voice them out. Also, feel free to add me on LinkedIn. Here's the link, or here's the link. And thanks once again.